A very warm welcome to honorable teachers, my fellow mates and everyone present here. My name is Chetan Duggar and today I am going to talk about tides. Not taking a much time, let's start the video.
So the first question that comes to our mind is that what is a tide? The tidal force produced by a massive object like the moon on a small particle located on or in an extensive body like the earth is a vector difference between the gravitational force exerted by the moon on the particle and the gravitational force that would be exerted on the particle it was located at the earth's center of mass. I believe you understand what I said. If not, in simple words, tides are the rise and fall of the sea level caused by the combined effect of the gravitational forces exerted by the moon, the sun, and the rotation of the earth. Time for an interesting fact. Isaac Newton was the first person to explain tides as the product of the gravitational attraction of astronomical masses. Now let's talk about the whole mechanism of tide on our earth. The pull on the near side ocean is the strongest because it's the closest, so it moves most towards the moon. The earth also moves towards the moon, but not so much as it's further away. Finally, the far side ocean moves towards the moon, least because it's furthest from the moon. These movements due to gravity create two high tides and two low tides as the earth rotates through 24 hours. But there's a big object that's missing from our diagram. Yes, I am talking about the sun. Does the sun also pulls ocean and make them bulge like the moon does? Yes, everything causes gravity, but the more mass of the object, the stronger it is. But the sun much further away than the moon reduces its tyndall effect about the half of the moon. When the sun and moon line up so that the gravitational attraction combine to make a super tide. This happens at a new moon, make the high tides higher and the low tides lower. This extreme tide is called a spring tide. When the moon goes into the first quarter, the gravity pulls in different directions and the sun actually takes away from the moon's tyndall effect. The high tides are not so high and the low tides are not so low. This moderate tide is called the neap tide. At the full moon, the moon and the sun's gravities line up again so we can get another spring tide. At the third quarter, the gravities are out of the wake again so we can get another neap tide. Each month the earth spins almost 30 times, so we can get nearly 60 high tides and 60 low tides. Of these, 2 are the spring tides and 2 are the neap tides. Whoa, bingo! Time for the another interesting fact. According to Guinness World Records, in Ukawa Bay, Quebec, Canada, a tide range of 16.6 meter was recorded as the highest tide ever in the year 1953. Now let's think something beyond reality. What would happen to Earth if the moon disappeared? The immediate difference would be the tides. Without the moon, tides would rise and fall at much slower rate. About 1/3 of the current fluctuation, the tides wouldn't completely stop moving as the sun has also some gravitational pull on the ocean too. The altered coastal ecosystem potentially destroying many of them and disputing the flow of energy, water, minerals and other resources. Entire ecosystem exists in the ocean areas between the high and low tides. In these spaces, many species of crabs, snails, barnacles, mussels, sea stars, kelp and algae rely on the daily coming and going of the tides for survival. These ecosystems in turn feed migrating and local birds as well as the mammals like bears, raccoons and deer. Earth could go from no tilt with a virtual no seasons to a drastic tilt with extreme seasonal weather changes and the ice age in just a few 100,000 years. Oh, thankfully there is no evidence that the moon is going to self-destruct or collide with another orbiter anytime soon.
That's all from my part. Hope you like the video.